Okay, so we're going to continue on in Chapter 3, talking about nuclear chemistry. In this section, we're going to cover nuclear decay. And nuclear decay occurs because an element needs to become more stable. So what you have with nuclear decay is you have a radioactive element that is unstable. I'll put in parentheses. This decays, so we'll put an arrow. You can kind of think of that arrow as an equation, equals sign. So the radioactive element is unstable. It decays to produce a new element and an emitted particle. The new element is more stable. Sometimes with nuclear reactions you can have a series of decay reactions, and this is called a nuclear decay series, but the end result is that you have a more stable element. Now we'll talk about different types of nuclear decay reactions. The first one we're going to discuss is alpha emission. And Chapter 3 is going to be a lot easier if you're familiar with the different types of particles that we've talked about. So we've talked about alpha particles, beta particles, gamma particles. We've also talked about protons, neutrons, electrons, and gamma particles. So I think I said gamma particles twice, but if you make flashcards of these particles with their mass numbers and charges, it will be much easier for you to work on Chapter 3. So the first type of decay we're going to talk about is alpha emission. And remember that an alpha particle has a mass number of 4 and atomic number of 2. So it can be written like this, or if you prefer to write it like this, the helium nucleus, you can do that as well. Be aware that an alpha particle can be represented both ways. So you need to be familiar with both ways. Now, uranium-238 is a radioactive element. It decays by alpha emission. So it decays to produce an alpha particle and a new element. The new element, if you look on your periodic table, the atomic number 90 corresponds to thorium. So with these equations, like I mentioned in the last lecture, the sum of the mass numbers on the left has to equal the sum of the mass numbers on the right. So 234 plus 4 gives you 238. 92 over here, so that checks out. And then 90 plus 2 gives you 92. That checks out. So I could ask you a question, since you know what an alpha particle is. Write an equation for the alpha decay of thorium-232. So, the alpha decay. So you have an arrow, and you're going to have an alpha particle. Now, if you wrote your alpha particle right here, that's fine as well, just as long as it's to the right of the arrow. So you have your arrow, your alpha particle. On the left of the arrow, you have to put thorium-232, and thorium has an atomic number, if you look on the periodic table, of 90. So thorium-232 decays by alpha emission to produce an alpha particle and then some unknown element. We have to figure this out. So we have the sum over here of 232. We have 4 plus something has to equal 232. So that something must be 228. So the mass number that we're going to put where that question mark was is 228. Okay, so those add up. Now we need to do the same thing with the atomic numbers. 90 on the left side, so 2 plus something is give us 90, so that's 88. So where the question mark was, we'll put 88. Look on the periodic table. The blue number that is 88 is radium. So you can write these equations already. This is what happens with alpha emission. So an element, a radioactive element, becomes more stable by emitting an alpha particle. The same thing can happen with beta emission. So a radioactive element can become more stable by emitting a beta particle. So, and this next one, next example I have, iodine-131 decays to produce an element and a beta particle. So this is a beta particle. And again, like with the alpha particle, there are different symbols that can be used. Be familiar with both. So this can represent a beta particle, or you can write E for electron, because a beta particle is the same as an electron. Now we need to figure out what the new element is. So if you look on the periodic table, atomic number 54 is xenon. Okay, so let's make sure that our mass number sums are correct. So 131 over here, so that looks good. 53 over here. 54 plus -1 gives you 53. So that checks out. Be very careful with beta emission. This is a negative number, so you subtract. So a lot of mistakes are made there. So I want you to write an equation for the beta decay of thorium-232. So, you know it's decay, you know there's going to be an arrow. So you have the beta particle here, and again, you could have written the beta particle right here. It doesn't matter, just as long as it's on your product side or the right of the arrow. So thorium 232, 90. So thorium 232 decays by beta emission to produce a beta particle and a new element. So we need to figure out what this new element is. And again, we're going to do the same thing. Add up the mass numbers on the left. Have to equal the mass number, some of the mass numbers on the right. So this is 232. This is 0 plus something gives us 232. So we know that question mark mass number must be 232. So that checks out. Now we have to do the same for the mass number. So we have 90 over here. -1 plus something has to give us 90. A lot of students will stick 89 here. 89 plus -1 will not give you 90, it will give you 88. Instead, we need to put 91. 91 minus 1 will give you 90. So, and that is, so if you look on the periodic table, that's protactinium, or Pa. So it's very easy to make mistakes on beta decay. Just be careful, be careful. Okay, on the next page, gamma decay or gamma emission results, since a gamma particle has a 0 mass number, a 0 atomic number, there is no change in the mass number or atomic number. This is useful in treating cancer, and a lot of times it's accompanied by alpha or beta emission. So since there's no change in the mass number or atomic number, it's really hard to see that in an equation, but we will always tell you what type of decay it is. If it's alpha decay, beta decay, or gamma decay, we will tell you. We don't expect you to know what type of decay occurs. Right, so radioisotopes are created by bombarding a stable atom with a fast-moving alpha particle, beta particle, neutron, proton, or electron. So created by bombarding a stable atom with a fast-moving alpha, beta, neutron, proton, or electron. So we've just talked about radioactive decay. There are instances where radioisotopes are desirable. Many biological experiments use radioisotopes to help determine what's going on. So there have been a lot of different radioisotopes used in understanding metabolic pathways in the body. So because these experiments tell us so much, there is a need for these radioisotopes. And transmutation is this process of changing one element into another. So in order to make radioisotopes, a stable atom has to be bombarded with a fast-moving alpha particle, beta particle, proton, neutron, electron, you name it. It has to be very fast-moving. And bombarded is just kind of smashing into another atom. So there are particle accelerators that need to be used in order to make these radioisotopes. And these particle accelerators can be miles long, so it gives you an idea of how long this accelerator must be to get this particle going fast enough to bombard into this stable atom to make a new radioisotope. So it's pretty cool. So let's review the symbols for the alpha, beta, neutron, proton, electrons. Remember, alpha has a mass number of 4. I'll do this in a different color. A mass number of 4, atomic number of 2. A beta particle has 0 mass, -1 charge. Beta, same as an electron. A neutron has mass, so 1, but no charge. And a proton has mass and also a +1 charge. It goes like that. And then an electron, no mass, but a -1 charge. So we've learned how to write decay equations. Now we're going to learn how to write transmutation equations. So I have a chemical process that's being described in words, and I want you to use symbols and chemical equation arrows to show what's happening. So boron 10 is bombarded with an alpha particle to produce nitrogen 13 and a neutron. So boron 10 is bombarded with an alpha particle to produce nitrogen 13 and a neutron. So the to produce tells you that there's an arrow. On the left side of the arrow we have boron 10. If you look on the periodic table, boron's atomic number is 5. So boron 10 is bombarded with an alpha particle. So they're going to be on the same side of the arrow. They are smashed into each other. When this takes place, new products are formed. So the new products are nitrogen 13. Nitrogen has an atomic number of 7. And a neutron. And remember, a neutron has a mass of 1, a charge of 0. So that is the chemical equation that I was describing in words. Now double check that your math checks out. 10 plus 4 gives you 14. So on this side, we need to have a sum of 14 as well. 13 plus 1 gives you 14. So that checks out. 5 plus 2, 7 plus 0. So 7 and 7. So that checks out. So I have another sentence describing a transmutation reaction. And I want you to figure out what radioisotope is produced. So argon-40 is reacted with a proton to produce a neutron and another radioisotope. What is the radioisotope formed? So I want you to hit pause and work on this. So hopefully this is what you got. Argon-40, 18, plus a proton gives you a neutron, and the missing radioisotope is potassium-40. So always double check yourself that your math checks out. 40 plus 1 gives you 41 over here. 40 plus 1 gives you 41. 18 plus 1 gives you 19. And then 19 plus 0 gives you 19. So those both check out. Okay, so I want you to fill in the missing symbol here. So go ahead and hit pause. Okay, so we have a sum over here of 59. We need to have a sum over here of 59 as well. So 59 minus 4 gives you 55. And then over here we have an atomic number, sum of 29. So we have to have 29 over here. 29 minus 2 gives you 27. So you end up with cobalt as your missing particle. So on the next page, we have a lot of review questions. So the main thing with Chapter 3 is it's practice, 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 knowing your particles. As long as you know your particles, you can really get through a lot of the questions in Chapter 3. So I want you to try and answer these questions without looking at your notes. So hit pause and answer these questions. When you resume, I will explain the answers. Okay, so a beta particle is 0, -1 beta. It is the same as an electron. In order to protect yourself from beta emission, a block of wood is sufficient. An alpha particle is 4/2 alpha, has the same mass number and atomic number as helium. Shielding from alpha emission is a few sheets of paper. A gamma particle is 0, gamma. In order to protect yourself from gamma emission, there are a lot of different items that you can use. The main thing is they need to be very thick. So the best way to shield yourself from gamma emission is with lead. But blocks of lead aren't very cheap. So a lot of times concrete can be used. So if you had a brick wall or a concrete wall, these would all be effective against shielding from gamma emission. And gamma particles have the highest energy. Okay, number 4, polonium-208 is one of the alpha emitters studied by Marie Curie. Write an equation for the alpha decay of polonium-208. So polonium-208 will go on the left side, then you'll have your arrow, and then the alpha particle, and then the other radioisotope form is 204-82 lead. So always make sure that your mass numbers add up to the right number and your atomic numbers add up to the right number. Number 5 has to do with beta emission. Be careful with beta emission because it's easy to make mistakes on that. So the first one, hydrogen 3(1) decays by beta emission, so you get a beta particle, and helium 3/2. Check your math. Lead 210 decays by beta emission to give you bismuth 210 and 83. It has an atomic number of 83. Fluorine 20 decays by beta emission to give you neon 20. Now number 6 and 7 were challenging. A lot of words, a lot of big atoms being thrown around here. Berkelium was first prepared at UC Berkeley in 1949. berkelium was made by alpha bombardment of americium-241, which also yielded 2 neutrons. So the yielded 2 neutrons part tells you these are in the products. Write the equation for the preparation of berkelium. So berkelium was a product, that's why it goes on the right side of the arrow. It was created by bombarding americium with an alpha particle, and it yielded 2 neutrons. So this is the correct equation. You can write 2 neutrons. You can write 2 out like I did, or you can write a big coefficient. Let me do this in a different color so it makes more sense. You can write a big coefficient, 1, 0, so that 2 is effectively multiplying the neutrons. So just keep that in mind if you do it that way when you're adding everything up. Now the last one, Californium-246 is formed by bombardment of a uranium-238 atom. If 4 neutrons are also formed, what atom is used for the bombardment? So Californium is the product. So product. Also in your products, we have 4 neutrons. So we need to figure out what you bombarded uranium-238 with to get Californium. So let's add everything up. We have 238 here, 246 plus 4 times 1 gives you 250. So we need to have a sum of 250 on the left. So that means my mass number is going to have to be 12. Do the same thing for the atomic number. So 98 plus 0 gives you 98. So we need to have 98 over here. 98 minus 92 gives you 6. So the atomic number, atom that has an atomic number of 6 is carbon. So it's carbon. So the more you practice these, the easier they will become. But I think one of the most difficult things about these equations is if you don't know your particles very well. So make sure you know your particles, make your flashcards, rewrite, redo your homework problems. And we will stop here for this section. So make sure you go ahead and do the homework problems that correspond to these sections. And just one more lecture left for Unit 1. So until next time.